Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.5, day 1, entitled Equations. And we have a lot of examples to go through today, so we're going to talk about several of these first objectives. We're going to talk about basically the first 4. Solving linear equations, solving a formula for a given variable, and then solving different types of quadratic equations. Remember, when you solve an equation, you're basically finding its solutions or its roots. And when we're going through the process of solving an equation, we're basically using equivalent equations. We can rework or rewrite the equation to make it equivalent to itself, just in a different form, so that we can solve it for the given variable. And some of the practices that we use when we're solving an equation is to add something from one side of the equation to the other, or subtracting. Whatever you subtract from one side, you need to subtract to the other side as well. Or multiplication. You can multiply something to one side of the equation and the other, or divide. But remember, you have to keep the equation balanced, so what you do to one side, you have to do to the other. So when we're solving linear equations, we want to first remember what exactly a linear equation is. And a linear equation just has one x term. So it's going to have this ax plus b. And so since x is just x, since it's not squared or cubed, that's what makes it linear. And some examples of linear equations are listed here on the left side. Notice that all of the x's are just x to the first power. Now you can multiply an x by a number, like 4 times x. You can divide it by a number, like x divided by 3. That's okay. Non-linear examples are like this one. Like you have the x squared. That's going to be a quadratic. You have the square root of x. That's going to be a root function. Here you have 3 divided by x. You can't divide by the variable. Okay. So our first example here, solving a linear equation. This is pretty basic. You should know how to solve this probably in freshman year. This is the type of problem that you knew how to do back then. And when we're solving this, notice we have a variable on both sides. So our first step in this problem is to get all of the variables onto the same side. And it really doesn't matter what side of the equation you move the variables to. Usually you're told to move the smaller amount. So 2x is smaller than 6x. So we subtract it over to the other side. And by doing that, it keeps our x value positive. We have a positive 4x now. Then our next step is to get rid of the number, get rid of the 5. So it's a minus 5. So we're going to do the opposite. We're going to add it over to the other side. And again, what you do to one side, you have to do to the other. And then now we can divide to get x all by itself. So x is equal to 4. Now there might be some other steps that you need to do first before you can combine all of your variables on one side and all of your numbers on the other side of the equation. You might have to distribute first. You might have to get rid of fractions. Remember, to get rid of a fraction, you want to multiply by the common denominator. So there are some other steps that you might have to do first. And of course, remember, we can always check our answer. We could take 4 and substitute it back in for the x's. We would get a true statement on both sides of the equal sign. Now, solving an equation, or I'm sorry, solving a formula for a variable is something that's a little tricky. Even in Algebra 2, students have troubles with this. And I like to think of it as just kind of like a little puzzle. You're just moving pieces of a puzzle around. We're still using those concepts that we saw in the last example. It's just that they're not numbers now. It's not a minus 5 on both sides. It's a g or an m. Okay? So we're going to be solving this equation for the little variable m. If you need to, you can put a little box around him so you can isolate him. And we have to get everything else away from him. So he's got a g that's being multiplied by him. So we'll have to undo that. We've got an m, a capital M, that he's being multiplied by. So we'll have to undo that. Remember, you undo multiplication with division. And then here we've got dividing by r squared. So we'll have to undo that, and we undo division with multiplication. So that would actually be where I would start. I would multiply both sides of this equation by the r squared. So what that does is it cancels out this r squared from the denominator here. So you'll have f r squared equals g m and then the capital M. Now the g is just kind of written out front, but remember we could think of like the g as being over a 1. So g is in the numerator. Okay. And now we have just finished solving for m, so I'm just going to divide by g and the capital M. And now we'll have the lowercase m isolated. So we'll have f times r squared divided by g times the capital M. Now you'll see lots of these different types of formula solving problems. They could have you solve for any of the variables in here. They could have you solve for g or m or even r. If you were solving for r, you would definitely want to multiply on both sides to get the r by itself. Then at this step right here, you'd kind of have to take a little side step. You'd have to divide by the f, and then you'd have to take the square root. So remember how to get rid of those exponents too. If you have exponents in problems that you're trying to get rid of, remember you need to take the root. Okay, now we're going to take a look at some quadratic equation problems. And remember, a quadratic equation can be really, really simple, like this one. We've got x squared equals a number, or it can be more advanced. But for now, we're just going to take a look at these that are really simple and really straightforward. Here, for example 5 in part A, we have x squared equals 7. And again, just like I said in the last example, if we were trying to solve for r, to get rid of that squared on it, we have to take the square root. So that's what we need to do here. We need to take the square root of both sides. Now remember, when you do that, technically, you're undoing the squared, but you're also producing two answers, a positive and a negative. Because we could take a positive square root 7 times itself and get 7, or we could take a negative square root 7 times itself and get 7. So don't forget that when you are physically taking the square root of something, when that is your work and that is your step that you're writing in, you're going to get a positive and a negative in your answer. Okay, same thing for part B. To start this off, we're going to take the square root of both sides. That squared term is already isolated. If it wasn't, we would have to get it isolated. So if it had, like on part A, if it was x squared plus 2, then we'd have to subtract that 2 over first before we could take the square root. But here, this x minus 5 squared, it's all by itself, it's isolated. So when I take the square root of something that's squared, remember that radicand pops out. Okay, so when we take the square root of both sides, remember that radicand pops out. So that's going to be the x minus 5 equals 3. And again, technically, when we are taking the square root of both sides, we want a plus or minus. Oops, and actually this is still under the square root. Sorry about that. Still the square root of 3. Now to finish getting the x by itself, I need to add 5 to both sides. And I can't add the 5 and the square root of 3 because they're not like terms. So the way I'm going to write that is just to put the 5 out front and then the plus or minus square root 3. We can kind of combine the expression, the two separate expressions, into one. Now, when we're solving more complex quadratic equations, they will look like this, the ax squared plus bx plus c. So they will have more parts to them. So when you have a binomial or a trinomial like this, we might have to factor first. And what we're actually using when we're doing that, when we're factoring first and then setting each little part equal to 0, we're using this zero product property. It tells you you have two things that you're multiplying together that ultimately equal 0. So that means that one of them has to be 0. So when we're solving more complicated quadratics, we're going to factor, and then we're going to set each little piece, each little factor equal to 0. So we have 3 more examples to work through, and we're just going to practice this zero product property in different methods. Now remember, before we can actually factor, we have to make sure our equation is set equal to 0. So in order to get this equation set equal to 0, I have to subtract the 32 over. So I will have x squared plus 4x minus 32 equals 0. And now I have my trinomial, so I'm just going to kind of focus on those 3 terms, and I'm going to have to use guess and check. I'm going to need the factors of 32 that add up to 4. The factors of 32 that'll get me to a 4 would be an 8 and a 4. So an x and an x and an 8 and a 4. And the way I get to a positive 4 is if the 8 is positive and the 4 is negative. So now those will add to a positive 4 and multiply to a negative 32. Now notice I've set it all equal to 0 now. That's the only big difference between the factoring we've done earlier in the chapter and now that it's an equation. You got to set it equal to 0. So then I take each little factor, each little parenthesis, and I set it equal to 0. That's the zero product property. And then I solve. So x equals negative 8 and x equals 4. And before you walk away, you want to make sure that you double check your answers, because sometimes one will work and one won't. Sometimes they both work, sometimes neither work. But if we were to check these, if we were to substitute them back in, we take the negative 8, put it in there, and square it, so that'd be 64, plus a negative 32 would give us a positive 32. So negative 8 works as an answer. 4 squared is going to be 16, plus 4 times 4 is 16, so that would get us 32. So both of those would be solutions to this equation. For example 12 now, we have another trinomial, except that instead of being x squared, it's x to the 4th. Well, don't be intimidated by that. We're still going to do a guess and check method, but instead of having x times x, we'll have x squared times x squared. Because if we actually multiplied x squared and x squared, we would get x to the 4th. And I still want factors of 4 that are going to get me to 5. So that's going to be 4 and 1. And I need to add up to a negative 5, so I need them both to be negative, and then that will multiply to a positive 4. Now actually both of these factors now in these parentheses can be broken down, because these are both a difference of 2 squares. So this will be an x plus 2 and an x minus 2, and this will be an x plus 1 and an x minus 1. And notice it was all set equal to 0. This original problem was set equal to 0, so we didn't have to move any terms over. And now I could set each of these little parentheses, each 4 parentheses, equal to 0 and solve. So I would get x equals negative 2, x equals positive 2, x equals negative 1, and x equals positive 1. And you can leave your answers separate like that, or you could say x equals plus and minus 2, and x equals plus and minus 1. You can kind of combine them, write them in a little shorthand notation like that. And again, we would want to check all 4 of our solutions. And when you check them, they will all work in that quadratic when you substitute them back in. And remember, that exponent tells you how many solutions you were supposed to have. It was x to the 4th power, so we actually ended up with 4 solutions. Okay, our last example then is still a trinomial, and it's all still set equal to 0. We're still going to factor. The only difference is that we have fractional exponents this time. So when we factor here, we just need to ask ourselves, okay, what times what, x to what power and x to what power would get me x to 1/3? And it needs to be the same thing. And it basically needs to be what 2 amounts I could add up to equal 1/3. So it's kind of like taking a third and dividing it in half. Well, 1/3 divided by 2, or times a half, is going to be 1/6. So we're going to have x to the 1/6 and x to the 1/6. And actually, the little trick there is to look at your middle term. This power on your middle term should match the exponents when you start to factor. And then again, I need the factors of 6 that are going to add up to a 1. So I'm going to need 3 and 2. And I need the 3 to be positive and the 2 to be negative. That way they add up to a positive 1, but they multiply to a negative 6. And again, this is still all set equal to 0. So basically, when you're dealing with a fractional exponent and you're doing guess and check, it's kind of like taking half of whatever that exponent, that lead exponent is. Okay, so now I have to set each of these equal to 0. Use that zero product property again. And we're going to have to get the x by itself, so I'm going to have to subtract the 3 over. And then here I would have to add the 2 over. And now I have to get rid of that 1/6 exponent. So to do that, I'm going to raise both sides to the 6th power. And you can do that in your calculator. Make sure you put a parentheses around the -3 because we want the negative to go with the 3. And if we raise -3 to the 6th power, we'll get 729. Same thing over here. To get rid of that 1/6, I'm going to 6th it and raise it to the 6th power. So I'll have x equals 2 to the 6th is 64. Now when you actually take these values and substitute them in and check them, only one of them works. If I take 729 and substitute it into my original equation, 729 to the 1/3 power is 9. 729 to the 1/6 power is 3. And then I'd have to subtract 6. That's not going to equal 0. So 729 is not an answer. When I substitute in 64, though, 64 to the 1/3 power is 4. And 64 to the 1/6 power is 2. 4 plus 2 is 6. Minus 6 is definitely 0. So yes, this is an answer. So like I said earlier, be careful. Check your answers. Don't just circle both of them and walk away. You need to actually take a moment and substitute them back in and check them. So there is your homework for this evening so that you can practice these concepts. Definitely practice because we've got factoring with fractional exponents, and that's a little tricky. That's a higher level skill that could definitely be on a quiz or a test. If you have questions, stop on in before school and see me.